Hello everyone. Here in this post, we would like to explain why do we need an angular acceleration and how this angular acceleration is related to the linear acceleration of a translatory motion. Let us consider a body is in the rotational motion about an axis that is shown with a dotted line. Let a particle of the body is moving from P to Q in an anticlockwise direction in a time t. We know we have already defined that though the different particles of the body are having different displacements, all of them are having the same angular displacement about the origin. So we have defined d theta as arc by radius, that is called angular velocity. We have also defined a term called angular velocity. Omega is defined as rate of change of angular displacement. Now we have acceleration in translatory motion as rate of change of velocity. Similarly, in rotational motion we can have a term called angular acceleration. Angular acceleration represented with the letter alpha. Angular acceleration alpha is defined as rate of change of angular velocity. It is just in line with the definition of acceleration. Acceleration is defined as rate of change of velocity in translatory motion. In rotational motion, angular acceleration is defined as rate of change of angular velocity, d omega divided by dt. So we can measure it with a SI unit of angular velocity is measured with a unit called radian per second, and there is another dt in the denominator, therefore there is another second, so it has a SI unit of radian per second square, and it has a dimensional formula of I can write further alpha as d by dt of omega is nothing but equal to d theta divided by dt. So d theta is not having any dimensional formula. In the denominator there is time twice, so it has a dimensional formula of t power minus 2. So angular acceleration is defined as rate of change of angular velocity. We can further write, as we have proved in the previous post, that v equal to r omega. That implies omega is nothing but equal to v by r. By substituting that value in the very definition of alpha, alpha equal to d by dt of, in the place of omega we can write v by r. But we can see now velocity by time is numerically nothing but equal to the acceleration. Therefore, it is nothing but equal to acceleration by r. That's the relation between linear acceleration and the angular acceleration. Therefore, a is nothing but equal to r alpha, or in the format of a vector, a bar equal to r bar cross alpha bar. Both of them are the vectors and their product is also a vector, and this kind of vector multiplication is called cross product of the vectors.